In this video, we will be talking about solving quadratics. Quadratics are formulas, or equations rather, that have an x squared in it. So there's a term with x squared written in the equation. We've got the steps here, but I'm going to go through the steps with you as we just solve some of these examples. So you can always refer back to the steps on your own. So the first type we're going to talk about is GCF, which stands for greatest common factor. So you find something that's in common between all of the terms. In other words, the largest number that divides into all coefficients and any variable that appears in every term to the smallest exponent. So GCF is the first factor, and then we have to divide that GCF out in order to find the second factor. So first I'm going to look at this coefficient of 5 and 20. And I say to myself, okay, what's the biggest number that goes into 5 and 20? So hopefully you're already thinking that it's just 5, right? 5 goes into 5 and 5 goes into 20. I can't use like the number 10 because 10 doesn't go into 5. Then I look at the x squared and the x. The term that goes into both of them is just x. Remember, you have to stick with the smallest exponent. So because there's an x in both, I can take out a single x. So now what I want to do is take and divide by my GCF. So my GCF is here, is 5x. We always write it off to the side. And then in my actual equation, I'm just writing it off to the side because I ran out of space over there. I'm going to divide out by the 5x on all parts. So I have 5x on the outside, parentheses equals 0. Inside the parentheses goes whatever was left over. So 5x squared divided by 5x. Well, 5's cancel. And then x's, I'm left with x to the first. X squared divided by x leaves me with x to the first. Or just x. You're welcome to get rid of that little first. And then minus, x's cancel. 20 divided by 5 is 4, and it's equal to 0. Now the last part is to actually solve it to determine the roots. So what I do is something that I like to call the t-chart. Because the entire equation is equal to 0, we have to set each factor equal to 0. So then you solve it for x. In this case, I divide by 5. So I get x equals, well, 0 divided by 5 is just 0. And then in this case, I have to add 4. So I get x equals 4. So the roots we write in these little brackets as 0, 4. Or you can just say x equals 0, x equals 4, but sometimes they will ask you to write it as the set, which is here. Okay, so factor first, solve second. Sometimes you have a quadratic that has 3 terms, and it doesn't have a number in front of the x squared. So in order to be a trinomial, 3 terms, and it does not have a number in front of the x squared. Cannot have a number. In order to do this, you're going to use the add multiply method. Add multiply. And we shorten this by calling it AM. So this is the AM method because you are going to add to the middle term and multiply to the last term. So you want to make sure, first off, that your equation is in standard form, meaning that you have the x squared first, the x second, the no x third, and it's set equal to 0 because otherwise you can't solve this. So we're going to set up our 2 parentheses and still have it equal to 0. X in the first spot of both, because when we multiply them, if we were to go back and distribute, x times x will give us that x squared that we need. So I need to add to negative 10 and multiply to 24. So off to the side somewhere, I'm going to find my factors of 24, like 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I think that's it. One of these pairs will help me add to negative 10. So if I want one of them to be positive and one to be negative to multiply to a negative 24, I have to put my signs in there. If I start with 1 and 24, there's definitely no way to get 10 out of that. Then if I look at 2 and 12, if I make one of them negative, am I able to get a negative 10? Hopefully you're thinking yes. 2 and 12 will help me get negative 10. And the trick to this, if you are struggling with positives and negatives, is that the bigger number takes the sign of the middle term. So the middle term was negative, that means the bigger number, 12, takes that sign. So negative 12 plus 2, right? Negative 12 plus 2 gives me negative 10. Okay, so we just factored. Let me tell you why we cannot use the 6 and the 4. If I make one of them negative, I have 4 minus 6, that gives me negative 2. Or if I have negative 4 plus 6, that gives me positive 2. So neither of those give me the negative 10 that I need. So now I'm going to T-chart. Because remember, we're solving these quadratics. X plus 2 equals 0. X minus 12 equals 0. And I solve by subtracting 2 and by adding 12. So final answer here is negative 2, comma 12. All right, and our last example is x squared minus 12x plus 32. So again, I'm going to label my a and my m because I'm adding and multiplying. There are 3 terms here. There's no GCF, nothing in common. So I put my a and m, and now I have to come up with numbers that multiply to 32. One times 32, 2 times 16, 3 doesn't work, 4 times 8, 5 doesn't work, 6 doesn't work, 7, and now I'm back to 8, so that doesn't work either. I did just notice over here that these words are kind of mixed up. It should say add to negative 10, multiply to negative 24, just like we did in the problem. And in this case, it should add to negative 12 and multiply to 32. Okay, so if you don't mind fixing that for me, I'd appreciate it. So now I'm going to set up my 2 parentheses, x in the first spot of both always. And now because I have to multiply to a positive number, that could either be positive times positive or negative times negative. And because we are adding to a negative number, I'm going to choose the minuses. Negative plus negative stays negative. Okay, so now I have to pick a pair that adds to negative 12. Clearly 1 and 32 will not. 2 and 16, that could make positive 14, positive 18, negative 14, or negative 18, depending on your signs, so that won't work. But 4 and 8 can definitely make 12. And because the signs have to match, since we are multiplying to a positive, if I have negative 4 plus negative 8, that gives me negative 12. Okay, so again, our signs are matching here because we had to multiply to a positive. So now I just set up my factors equal to 0. I add 4 to both sides. X equals 4. And in this case, x equals 8. So curly bracket, 4, comma, 8 is the solution. Okay, so that gets you factoring and solving quadratics with GCF and add multiply method.